Hi guys, I'm Nyasha. So today I'm going to be doing normal distribution, right? So yeah, sit, relax and enjoy. I'm actually going to be doing a question in the module on page 216, number 20A. It reads as, suppose the duration of trouble-free operation of a new vacuum cleaner is normally distributed with mean 530 days and standard deviation of 100 days. And the question reads, what is the probability that the vacuum cleaner will work for at least 2 years without trouble? So when you're doing question 20, once it states that normally distributed, you should automatically know that you're going to use the normal distribution. No two ways about it. So to start with, we have to state our distribution before we even go to the question. That way you earn 3 marks just from writing what's on the question. So yeah. I'm going to state the distribution. Actually, let x be the number of days, or maybe the duration. I'll call it the duration as the question states. Let x be the duration, right? Then we state the distribution is distributed as normal. Our mean, which is 530, and our standard deviation. But you should, however, know that when you're stating the distribution, you state as the variance, not the standard deviation. But as we all know that when it's standard deviation, for you to get variance, you have to square the standard deviation. So I would put it as 100 squared. This will classify as the standard deviation, right?
Wouldn't that be the variance?
Oh, sorry, the variance actually. Thank you. Then we actually move on to the question. What is the probability that the vacuum cleaner will work for at least 2 years without trouble? We're given 2 years. What we have to first consider is that this is 530 days, right? And 100 squared days. But we are told that probability of our x being at least, of which at least means that it's from 2 years and moving forward. So it's going to have to be probability of x being greater or equal to, because we have to include the 2 years, it's from 2 years or more, yeah. So it's going to be 2 years, yeah. Now, the trouble comes when we have to convert a few things. This is 2 years and this is 530 days. This has a connection in that a 1 year is equal to 365 days, right? And we have 2 years here, so 2 years is going to be equal to 2 by 365, and this should give us 730. Thank you. 730 days. This automatically means that probability of x is greater or equal to 730 days. Yeah.
Nasha,
Yes.
for the normal distribution, is it necessary for me to say that it's greater or equal to? Because my graph already takes care of the equal to. Because is it necessary for me to have the greater or equal to for the normal distribution?
Well, I don't think it's that necessary, but I was just interpreting according to the question because it says at least. So people usually get confused whether is it included or not included. Just interpretation of the question, but it's not that necessary actually. Then to move forward, Oh yeah, as I was saying, it's necessary for us to change from years to days in the case that we need to have the same units with the normal distribution up here. So we can't use years and days because they're not in the same units. So that's why I changed it to days. Then we move forward to calculate probability of x being greater than or equal. Oh, we can just as well move it to greater than 730 minus 530 divided by the square root of the variance, which is 100 squared.
Sorry.
Yes?
Isn't this supposed to be Z now? Since we are converting it from.
Oh yeah.
Since it's standardized.
Thank you. This is actually a standardized thing. Then we calculate, that's 730 minus 530, that's 200 divided by 102. Right. Then from here, we know that this is probability of z is greater than 2. Then we move to our tables, right? Which is on page 236, that's table 1. Yeah. We know that for our tables, it's always. Am I doing the right thing? Okay. Okay, we know that for our tables it has to be a probability. Okay, I'll just write a random thing. Probability of z being less than something here, right? Of which, for this formula, we have probability of z being greater than 2. So just to change this, which should give us 1 minus, because we need to take we need to get the probability this side. Yeah, we need to get the probability on the right side of 2 when I'm pressing this side. Yeah, the right side of 2. So we have to get probability of z being less than 2, which means we have to deduct this red section of the graph. So this statement will enable us to read the graph because our graph is stated in the terms of having less than formulas. So yeah. So just to go back to the graph, we go look for probability of z being less than 2, and which is 0.97725. Right. Then 1 minus 0.97725. Then just to get the difference, should give us a final answer.
0.2275.
2275.
Yeah.
0.0275.
02. So is that right?
No, it's 0.02275.
2275.
Yes.
Okay. 0.2275.
Yeah.
Okay. And that's our final answer. Thank you.
You select